My name is Alina Polonia. I am a geologist at the Institute of Marine Sciences that belongs to the Italian National Research Council. I work in the field of marine geology and geophysics to study active tectonic processes and how do they trigger earthquakes and tsunamis. The final goal of my research is to reconstruct past earthquakes to prepare protection strategies against future events. I do not know exactly when I decided to be a geologist, and my first inspiration comes from my childhood when I experienced a big earthquake which destroyed my house and caused about 1,000 causalities. I think that this has deeply inspired my life. Before the earthquake, the ground, for example, was something very stable in my imagination. And the direct experience of the shaking and the perception of the dynamic nature of the earth was on one side a source of fear and insecurity, but on the other triggered by curiosity. And 15 years later, in fact, I started my studies in tectonics, earthquakes and tsunamis, and this probably was not by chance. We study the geology below seas and oceans, thus we do not use compass and hammer like classical geological studies on land. And since it is not possible walking on the seafloor and touch the rocks, we mostly use indirect observations such as sonar images and samples collected using long tubes penetrating below the seafloor, and we call them cores. This is a seismic section, that is an image of the Earth interior obtained using acoustic energy, so a sort of echography which can penetrate very deep, up to several kilometers under the seafloor. The sound travels down into the water, reaches the seafloor and the sediments and rocks below. And the echoes recorded to the surface from the ship are plotted one close to the other, forming the image of this seismic profile. What we study in such images is the way the sediments are stacked and deformed by tectonic forces. During our oceanographic cruises, we collect long cores of sediments, which are then transported to our laboratories and analyzed with many different instruments. We collaborate with many colleagues worldwide using different methodologies such as geochemistry, micropaleontology, sedimentology and biology. The final goal is to identify and date the effects of past earthquakes and tsunamis as they are recorded in the sediments. In this way, we can compile a catalogue of earthquakes and their consequences that goes far in the past, in the prehistorical times, when no one was there for reporting. And this is important to assess the seismic hazard of any study region. And the marine environment where sediments deposit continuously is a very conservative record of these events. This is an example of a sliced core which was collected in the Mediterranean Sea at about 4,000 meters water depth. You can see all these beautiful colors and how do they vary throughout the core. Any color change represents a change in the environmental conditions. This section includes a 10,000 years long record with major geological events such as earthquakes, tsunamis, landslides and sea level changes represented by changes in the sediment character. And these can be interpreted such as a sort of barcode for which we know only partially the decoding function. And for this reason, sometimes I feel like a detective interrogating sand grains on past catastrophic events that can be considered a sort of natural crimes. Sand is very common on beaches, along rivers or in deserts, but we rarely stop to think about its origin and about the complex and mysterious history of each grain, whose formation is caused by the effect of chemical and physical processes that continuously shape the Earth's surface. But when it is deposited in the marine sediments, the sand grain remains relatively stable, preserving a lot of information about its transport pathways, and reconstructing this travel is the basis of my work. And using sand to tell the story of the Earth is a complex exercise which requires analyzing the individual grain composition, their age, structure, and also the shape. But I think that the poetic intuition of William Blake, who was able to capture the world in a grain of sand, is very inspiring for marine geologists. After many years spent in the world of scientific research, my feeling is that beside all very useful specialized works, the most important frontiers will be the demolition of the rigid barriers between different disciplines, which would open our mind to a systemic vision of Earth processes and to perceive the deep interconnection between natural processes and our own existence. I think that we should not be afraid to explore the unknown without preconceptions. And from my personal experience, I can say that any original work comes from the resonance rising when what has been learned is forgotten, also for a while. It is in these moments that a creative potential leads to the emergence of something new to be explored. And I wish you to be able to follow these insights and do always your job with pleasure and with a never-ending desire of learning.